Hello.
Yes, ma'am.
Good afternoon. I was checking audio.
Yes, thank you, ma'am.
Hello.
Good afternoon, everyone. Registrations are open. In the meanwhile, we would like to share a video on star labeling shared with us by Engineer Balkar Singh, former Joint Director of PEDA, and made by BEE. I would request the moderators to kindly play the video, please.
Mansi ma'am,
Yes, sir.
we can skip the video now, and it's not running due to some technical problem. You can straight away start the.
Okay, sir. Let's start the program.
Yes.
Good afternoon, ladies and gentlemen. Hope you are all having a very fine day today. I, Architect Mansi Ghavri, welcome you all to this deliberation of webinar on energy conservation and energy efficiency. This program is an initiation of Punjab Energy Development Agency, and it brings me immense pleasure to share that PEDA is celebrating Energy Conservation Week in the entire state of Punjab. Sakar Foundation from Chandigarh has been given the responsibility of organizing webinars for the stakeholders in this entire week. Energy efficiency, in simple terms, it means judicial utilization of energy, or to use the energy to its full potential. This can be done through various measures. One of the best ways to achieve that is to aware the holders of the various possibilities to do so. These webinars are specially designed to talk on different subjects like energy efficient architecture, green materials, energy efficient lighting, HVAC programs, star label appliances, and many more to spread awareness in our country. I extend my warm welcome to all the members from various institutions, Department of Planning, Agriculture, Department of Water Supply and Sanitation, PSPCLs, Department of Technical Education and Industrial Training. I welcome you all. Moving forward, I would like to invite Engineer Gurpreet Kaur from Government Polytechnic of Women Jalandhar to give her welcome address. She is a lecturer in the Department of Information and Technology. Over to you, ma'am.
Thank you, Mansi ma'am. Very good afternoon to all of you. I'm lecturer Gurpreet Kaur of Department of Information Technology. I welcome you all today on 5th day of celebration of Energy Conservation Week. Today's webinar on energy conservation and energy efficiency is organized by Punjab Energy Development Agency, PEDA, with the support of Bureau of Energy Efficiency and Sakar Foundation, Chandigarh. I welcome all officials, staff members, and authorities of PEDA to this program. I extend my warm welcome to all the officers and staff of Department of Planning, Agriculture, Water Supply and Sanitation, PSPCL, Department of Technical Education and Industrial Training for their participation in this webinar and other professionals. I give a warm welcome to Principal GPC Jalandhar, Mr. Rajesh Kumar, all HODs, faculty and students. Government Polytechnic College for Girls, Jalandhar, was established in year 1970. The college is approved by All India Council of Technical Education, New Delhi. We have well-qualified and incredibly diverse faculty who believe in innovation and uses modern method of teaching. We have 8 diploma courses running in our college, namely Diploma in Architecture Assistantship, Chemical Engineering, Electronics and Communication Engineering, Information Technology, Computer Science Engineering, Library and Information Science, Modern Office Practice, and D Pharmacy. I also welcome today's speaker, Architect Surinder Bagga, Engineer Neeraj Arora, and Architect Sanjay Goel. I highly appreciate them as they have spared their valuable time to share their knowledge with us. Warm welcome goes to architects Guneet Khurana, Arpan Agarwal, and Ramneek for their support. In addition, I welcome our supporting organizations, Indian Institute of Architects Punjab chapter, and all the members, executive members, office bearers of IIA Chandigarh and Punjab chapter. I welcome architect Mansi Ghavri. She will be comparing this program today. I congratulate all the members involved and hope this event will be beneficial and informative to all the participants. Thank you. Over to you, Mansi ma'am.
Thank you so much, ma'am, for welcoming all our attendees and all our esteemed panelists and guests. Now, I would like to request Architect Guneet Khurana from Amritsar to introduce us with the proceedings of the webinar. Guneet sir, over to you.
Thank you, Mansi. So, my name is Architect Guneet Khurana, and let's discuss a brief about energy conservation. Energy conservation has often been referred to as the fifth fuel, the other four being so primarily or fossil fuels of coal, oil, gas, and nuclear or hydroelectricity. This emphasizes the importance of reducing the amount of energy used, not only nationally, but also internationally. The simple fact is that the world's reserves of fossil fuels will eventually run out depending on the rate of use, and therefore, if the consumption of these four forms of energy are reduced, the existing reserves will last longer. Research and experimentation could lead to those reserves currently available but uneconomic to recover and use being rendered economic, thus extending further the number of years before these non-renewable sources of energy do eventually run out. The amount of worldwide energy reserves and life is variable according to the source of information used. Thus, at some time in the not too distant future, maybe less than 100 years, oil, gas, and uranium will no longer be available. Every effort is required to reduce the world's energy demand to cater for this event. The earth provides enough to satisfy every man's need, but not every man's greed. And it was very well said by Gandhiji. There are some hard facts on why energy conservation is a must here. We use energy faster than it can be produced. Coal, oil, and natural gas, the most utilized sources that takes thousands of years for formation. Energy resources are limited. India has approximately 1% of world's energy resources, but it has 16% of world's population. Most of energy sources we use cannot be renewed and reused. Non-renewable energy sources constitute 80% of the fuel use. It is said that our energy resources may last only for another 40 years or so. We save the country a lot of money when we save energy. About 75% of our crude oil needs are met from imports, which would cost about 1 crore, 1,50,000 crores a year. We save our money when we save energy. Imagine your savings if your LPG cylinder comes from an extra week or there is a cut in your electricity bill. When we use fuel wood effectively, our fuel wood requirements are lower, and so is our drudgery for its collection. Energy saved is energy generated. When we save 1 unit of energy, it is equivalent to 2 units of energy produced. Save energy to reduce pollution. Energy production and use account to large proportions of air pollution and more than 83% of greenhouse gas emissions. An old Indian saying describes it this way: the earth, water, and the air are not a gift to us from our parents, but a loan from our children. Hence, we need to make energy conservation a habit. Hence, today's event. Thank you.
Thank you so much, Guneet sir. Thank you for emphasizing the need to celebrate this Energy Conservation Week. Now, let's start with our sessions. I would like to invite our first speaker, Architect Surinder Baga. Architect Surinder Baga is the principal architect of Sakar Foundation in Chandigarh. During his professional career, he has held many reputed positions as chairman of IIA Chandigarh Punjab chapter, chairman of IIA Publication Board, and editor of Journal of Indian Institute of Architects. Presently, he is the head of Chandigarh sub-chapter of FSAI, chairman of GEM Chandigarh chapter. He will be introducing us with the proceeding. He will be deliberating a session on the energy efficient architecture. Over to you, sir. Baga sir, can you hear me?
Yeah, just a second.
Okay. Here is our speaker. Over to you, Baga sir.
Yes, thank you, Mansi. Thank you so much. There's some technical problem in the internet connections. It's a bit unstable. So the inconvenience is deeply regretted.
Sir, in the meanwhile, you can tell us about the webinars that you've been hosting to promote energy efficiency in Punjab.
Punjab Energy Development Agency is organizing a 7 days program, which is a week-long program to create awareness in all the departments of the state. And apart from that, there is a separate program going on with the architecture engineering colleges. And likewise, some debate in the state of Punjab for the school children. The aim is to create awareness about energy conservation. So I can start my presentation. My topic is energy efficient architecture. I would like to mention that in all the holy scriptures of which are available, there's a mention about saving the environment and saving the Mother Earth. To begin with, these are the this is a shloka there is a verse in the Holy Quran, which is a Hindu sacred scripture. It highlights the importance of a tree in our lives. Likewise, there are many shlokas in the Holy Guru Granth Sahib, which are highlighting awareness of saving the environment. Similarly, Quran में भी बहुत सारी आयत दर्ज हैं which are advising the mankind to save Mother Earth. Bible also versifies similar advice to the mankind. So let's have a historic overview. In the ancient India, when this Mohenjo-daro township was in the 2600 BC, the care was taken to design this, keeping in view the geography, keeping in view the local climatic condition, using local, and these kind of houses were made in the Mohenjo-daro township. There were no windows. They have brick jalis. There was no decoration. You can see the houses were very modern, and local bricks were used. And that was a township where that has a proper sewerage system, designed sewerage system in those times in 2060. And in nearly 200 years of the Mughal, India's architecture was almost at the peak of its perfection. And in this, you can see all the buildings are having use of local materials. There were projections in the Fatehpur Sikri fort built by Akbar. Then they see the uses of water, the uses of stone, jali. This is the picture of Red Fort. You see, there was no electricity at that time. There are water channels inside the verandas. In the desert of Rajasthan, in Jaisalmer, these havelis were created with local stone, and you can see windows are protected from the dusty wind and the hot climates. They introduced courtyard. They use this kind of architecture to protect the interiors from the harsh climate. You see how windows are protected, and the streets were very narrow so that they get automated with the buildings itself. These streets were there at Jaisalmer. India has very advanced systems of water harvesting. This is a Chand board in Jaipur, and there are many in India, in other parts of India, where water conservation techniques were introduced by
Architect Baga, can you hear me? I think his video, there has been some technical issue with his system. So yeah, he's back here online. Mr. Baga,
yes,
can you hear
me?
me?
Second. Yes, ma'am. Yes, please. Yes. Hello. Am I audible?
Yes, sir, you are audible.
Okay. So these kind of buildings were made in India way back. Neeraj? One second, please. Yes. In the South India, Jahangir Mahal was made in 17th century. You can see the courtyard planning, thick walls, and the shaded walls and openings. So this was the kind of architecture India was needing. When during the British Raj, all the buildings made in Delhi, built in Delhi, they were designed according to the local climate of Delhi, because we were having local use of local materials were introduced, small windows were there, thick walls were there. You can see the Parliament House. And even in the Secretariat in New Delhi, you can see projections are there, small openings are there. these projects are designed by British architects, but yet still they have taken care of the local climatic conditions. This is the main point. When Corbusier came to India, Pandit Nehru invited him. On reaching Chandigarh, the first thing he did was to study the climate of Chandigarh. Even the emblem of Chandigarh, which is open hand, is designed to give the sense of wind direction to the local people. Chandigarh has a artificial Sukna lake, which has considerably improved the microclimate of the city. That was that was designed by Corbusier with this same. And Chandigarh is the only city where we have 35% of the green spaces. In cities like Kolkata, we have only 2% green areas. In High Court building, where we have a double roof, and this you can see how the glazing, how the windows are protected with a combination of horizontal and vertical louvers. And in Capitol Complex, this is the Assembly Hall with Vidhan Sabha. Corbusier introduced, shallow water bodies so that the users can get cool breezes. In a Secretariat, the care has been taken to orient the building in a wind direction, and the verandas the glazings are very deep, about 12 feet deep, so that they don't get heated up with the sun rays. And this is the Tower of Shadows in the Capitol Complex, which was designed and implemented by Corbusier with the aim to educate architects and engineers about how to design louvers around the buildings. And in the middle of 90s, a very famous Indian architect, Charles Correa, has built LIC building in Delhi. And in this building, first time probably, there was a huge glazing on the northern side. And there was a lot of hue and cry that, this architect has gone mad and he is designing buildings with a lot of glass in a hot and humid climate. But to my mind, that was very sensible, because we can always put glass on the northern side. It never gets heated up. And after that, this is our PEDA Bhavan. PEDA Bhavan was a very nice building, very nicely designed building. But when the building was nearing completion, a senior bureaucrat of the Punjab government has forced the architects to change the design at last minute and put glazing all around. He was giving instructions to the architects that I want Gurgaon like building in Mohali. So that was the major blunder he has done. And the result is that this building never gets cooled, even in spite of having tons of air conditioning load on this. And the building works like a furnace. Buildings consume nearly 48% of world's total energy. That is, the surveys are indicating this. And when we design buildings, we have to have very sensible approach. And India is a huge country, and it is further subdivided into 5 climatic zones. One is Jammu Kashmir with parts of Himachal, that is cold and cloudy region. And the composite region is the area which is light golden yellow color. And hot and dry region is Rajasthan and parts of Gujarat. The warm and humid region is the coastal belt of India, and moderate region is a small pocket near Pondicherry. And now I will briefly explain, when we design buildings in a composite region, the design strategies are given here. It says that we have to resist heat gain in summer and resist heat loss in winter. And we have to promote heat loss in summer and in monsoons. And following these guidelines, we designed a project which is a Red Cross Bhavan in sector 16 in Chandigarh. It is facing the famous Rose Garden. The building is oriented to face north and south direction. The project got delayed by nearly 1 year because we were arguing with the Chandigarh administration that we should have a proper orientation, and the zoning plan was wrongly made nearly 50 years back. So we got the revised zoning plan sanctioned from the government, and with the help of the then chief architect. And ultimately, the building was designed with a long struggle to have a right orientation. And in this project, you can see there are small windows and they are properly protected horizontally and vertically. And currently, we are involved in designing a big university, that is City University on the Firozpur Road near Ludhiana, Jugrao. And this is a 50-acre project where all the buildings are oriented to face the north and southern direction. The major facade of the building is facing northern side or the southern side, because this is considered to be the best side for any academic building. And we faced a lot of arguments with the client, the owners, to convince them to put the buildings in this manner. And very few people will be knowing that most of the buildings in the Punjab University campus are oriented in a similar way. And we participated in a competition of Hareda office building long back. And in this project, we introduced that if we have these shafts which are which are tapered at a particular angle, so there's no need to introduce mechanical ventilation in the building. These shafts are scientifically designed in such a manner so that the hot air which is sucked from inside can go up and can escape through the top openings. This is the plan. We have introduced the central courtyard and rainwater harvesting and all that. And you see the projections are also designed very scientifically, so that windows get properly shaded. Then we designed this church in Chandigarh long back, and this building was rated as one of the best 41 energy efficient buildings in India by the government of India and TERI. And in this building, you can see there's a vaulted roof on top, which is painted in a white color to reflect incident sun rays. And the building facade is in a light color, and the windows are very small. And cavity wall is, all around the building to keep the building cool. And the result is the building works really very well. Then next is the Bal Bhavan, which we designed in Mohali. Here, this is the western side. Western side gets very heated up in our kind of a climate. So what we have done is we have put all the toilet blocks on the front side, which is normally people don't advise. What we decided is that, if the toilet blocks get heated up, at least the heat will not be transmitted to the dormitories where children are staying. You see how we have shielded the windows with balconies and the projections, and there are the building has open to sky terraces also where children can enjoy the weather. Then we designed this primary school wing of the Yadvindra Public School, and this was a design competition, and we have won this competition. And Captain Amrinder Singh, the current Chief Minister's mother, Maharani Mohinder Kaur Ji, she was the chairman of the trust, and she gave directions that I don't want any tree to be cut from my school, and I will give the project to that architect who will not cut any tree. Many architects submitted their design proposals, and she has chosen our design with the help of the experts and other jury members. And as a resultant, we designed this building where, when this building was made, we have not cut any tree. And we have shielded the windows properly. And you see, this is the corridor of the primary school. And there are cutouts on the either side. And these cutouts facilitate internal air movement and brings in a lot of light. So the interior becomes very nice, and the noise in the corridor is not allowed to enter the classrooms. Classrooms can get a better quality of education because there's no noise at all because of these cutouts. And then we designed a youth hostel at Patiala long back. Here also you see these, we have shielded the windows and the doors and the glazing in a proper manner. These balconies are segregated from each other to ensure the privacy to all the residents. And to drain the rainwater, we have provided rainwater spouts. And a school, we designed a Christian school, Baptist school in Chandigarh. Again, you can see the windows are properly protected with a combination of horizontal and vertical louvers. You can see this model. We have planned courtyards, two smaller courtyards and two bigger courtyards in the plan. This is a very traditional kind of a planning, but we opted to have this because this works better in Indian climate. Then we designed about 1,200 rooms for the postgraduate students of NIT Kurukshetra. Here also we have designed, there's an individual small room for the postgraduate student with a balcony attached, and all the rooms have independent balconies, and all the rooms have glazing which is properly protected. And there are courtyards, and there are other features to keep the building cooler. And then we designed this convention center in New Delhi for the Ministry of Agriculture, and we got a first prize for this 40 crore project. In this project, we have tapered the tapered the roof at a particular slant, and this entire roof is made of solar panels, you can see in this model. Apart from this, we have taken care that no tree is cut and proper rainwater harvesting is introduced and green materials are introduced also. And long back, we have one prize from HUDCO for designing a energy efficient housing in Jalandhar. In this project, you see, you can see this sketch. We have provided earth berms at the bottom. We have provided planters in front of the windows. We have provided this perforations in the parapets, and there's a staircase tower in the middle which has openings at the top, and those openings help in sucking hot air from the surrounding rooms, and that hot air can escape through this stairwell. Ultimately, the building remains cooler. And we happen to design a very small library in a small village in the Moga district, which is Lopon. And in this library, this is called a green library in the village. There's a cooling tower on the top, and this cooling tower cools the air, and the cooled air is thrown down in the interiors of this library, and ultimately the library gets cooled air. And you see the windows. The building is having north and south orientation, and on the eastern and western side we have cavity walls because we get a lot of heat from those sides. And even the book racks are placed on the along the external walls, and the windows are kept above that. You can see in this picture, windows are above the height of the book rack, and these small windows are deeply recessed so that there's no rain or no sun rays can fall on them. The resultant is that this building remains very cool, and the whole village is using this apart from the neighboring villages. And the next climate category is hot and dry. That is Rajasthan primarily. Here the design mantra is different. We have to resist heat gain, and we have to promote heat loss at night. And we happen to design a township for Indian military. It's a married accommodation project for Indian military where we designed more than 800 houses. And it was very difficult to convince the army authorities to design a building, design this whole township to suit the local climatic conditions. Then we opted to have orientation of all the blocks facing north and south, because in a hot and dry atmosphere, only this kind of orientation works. Ultimately, we could convince the authority to have this orientation. They were wanting just the opposite. And this is the township, this is the housing we made for military officers and the military jawans. You see, we have used light color to reflect the sun rays, and we have all the balconies and all the windows are shaded, and the self-shading facade design is introduced. And we opted to have not cutting any tree from in the side. The planning of the whole township is done in such a manner. Warm and humid, warm and humid climate is the coastal belt of India, where the design mantra is, the design strategy is to promote ventilation. We happen to design a youth hostel in West Bengal in the place called Bardwan, and where this number 4 is written in this plan. This is a dormitory for the students. This particular dormitory, you can see in this plan, have 6 openings. One dormitory have 6 openings because we don't get proper electricity in that remote area. Ultimately, what happens is, when there's no electricity, the climate is very humid. We just open all the 6 windows, and this becomes livable. At least the students or youngsters who stay there, they can live there at least. So this is the kind of building we conceptualized for West Bengal. Because of a lot of rainfall and humid conditions, even the color scheme of the building was chosen in such a manner so that it doesn't get blackened easily. And to drain the rainwater from the roof terraces, this rainwater spouts were introduced. And you look at the window boxes, how we protected the windows from the rain and the sun. And the moderate zone is one small pocket near Pondicherry. Here you see this is a house designed by Vijay Narnapati architects, and a very unique kind of a house I'm quoting, because this house have cavity walls, this house have earth berming, this house have insulated roof, this house ensures cross ventilation, and it has solar panels, and everything is there in place. And this is considered to be one of the best house climatically. And next category is a cold and cloudy region, which is Kashmir. And in this Kashmir, we happen to design one project which is meant for the people who got injured or incapacitated during insurgency. When we design buildings in such a climate, we have to take care that we have to resist heat loss and promote heat gain. Because when we design buildings in India, designing buildings in a cold climate is altogether a different game plan than designing buildings in Rajasthan. And this is the project we designed in Kashmir. Here, the snowfall is a serious problem. Snow, when it falls on the roof, it gets accumulated, and it is very difficult to clean it mechanically or physically. So we tapered the roof in a particular manner, on a particular angle, and the snow automatically falls on the ground. Hence, thereby the hassle of snow clearance from the roof is saved. And the plan shape is swastik shaped, which is a sacred Hindu symbol. And in the last, I would like to show you a small video that how waste materials can be utilized for making houses. This is an example taken from Nigeria. These are they have a
have lived in houses made of mud for centuries, but the cost of traditional house building is getting higher by the day. A house made of plastic bottles costs $15,000, 1/3 of the usual price, making it more attractive. And as there's no shortage of the raw material, which is basically free, there's no reason why anyone should resist. The developers are looking for government support to expand the idea, hoping that cleaning up the streets and creating a much-needed greener economy will be a good impetus for government involvement. Ibandege Al Jazeera, Kaduna State, Nigeria. It's an ingenious way of
Bhaga sir, we cannot hear you.
Hello.
Now you are audible. Sir, again, your audio is not audible.
Hello.
Yes, sir.
So this video was showcasing how waste Coca-Cola bottles can be utilized to make houses for the poor people, and Nigeria is already doing it. The bottle is filled up with sand, and the bottles are piled up one above the other, and they are tied with a nylon rope. The conclusion of my whole talk is that India is a big country, it's a huge country, and there is a need to design buildings keeping in view the local topography, keeping in view the local climatic conditions, and we have to see, we architects and engineers have to see in which zone we are falling in, and accordingly we have to design the buildings. Thank you so much. Thank you so much.
Thank you so much, Architect Bhaga. I think so, apart from the technical difficulties, your message was loud and clear that India is a huge country which has 5 different climatic zones, and each zone has its own design parameters. And we as architects, being the professionals and stakeholders in this industry, need to take a responsibility and should design buildings to suit the local climatic zone rather than copying the Western traditions or materials. Building should respond to its local environment in order to sustain and be energy efficient. As you said in your presentation that our ancestors were well aware of these facts, which we somehow have, I think so, in the process of developing or copying from the Western nations have overlooked. I think so, sir, you have given us a very good example of how waste can be changed into making something more energy efficient and more sustainable. Thank you, sir, for your presentation. Moving on to our next speaker, Engineer Neeraj Arora. Mr. Neeraj Arora is associated with the Associated Chambers of Commerce and Industry of India, New Delhi, as Senior Director. Mr. Arora is the head of GEMS Green Certification Program, ESOChem National Council on Environment and Climate Change, and ESOChem's National Council on Education. He will be talking about GEMS certification. Over to you, Mr. Neeraj.
Thank you, Architect Mansi. Thank you for inviting me for this session. First of all, I would like to extend my gratitude to PEDA and Bureau of Energy Efficiency and Sakar Foundation for organizing this 1 week energy conservation, energy conservation week you are celebrating. And the topic is very relevant in today's scenario, energy conservation and energy efficiency. So, as mentioned, I am Neeraj Arora. I am Senior Director at ESOChem and look after the GEM Green Building Certification Program of ESOChem mainly. I have 2-3 other verticals also, the sustainability, environment and climate change, water efficiency and education. But my today's talk will be on GEM Green Building Certification Program of ESOChem. So I'll take a minute of yours and would like to share my presentation. Just a minute. So I'm keeping my video off. My presentation and audio will be better. So just a minute. So I hope that my presentation is visible.
Yes, sir.
Thank you so much. So GEM is basically the green and eco-friendly movement. We call it movement because we have designed this program such a way that this green building certification will not be very costly for the developers. It will be, this program has been so written so that even a layman at site can understand this program. So by this way, we want this program to be designed for a common people, for all the projects, and that's would like to make it a movement. And why movement? Because ASSOCHAM is the largest industrial association of the country. We are the oldest and largest, I must say. This year we are celebrating our 101st year, and we have various regional chambers, trade associations, and other commerce bodies. They are all part and parcel of ASSOCHAM. This way, we have around 450,000 industry members associated with us from all across the country. Bombay Chamber of Commerce, PhD, Kochi, and many other chambers, they are part of ASSOCHAM. So that way, this is the largest and oldest apex industry chamber of the country. So with the support of this long member database, we would like to make this a movement. So friends, this is a green initiative of ASSOCHAM to care for the Mother Earth and to complement in India's sustainability movement, and formed a council for green and eco-friendly movement that executes the GEM certification program. And our objective is to promote environment-friendly green building design and construction. So friends, these are some basic concepts. We are, listening since last 15-20 years that, the green buildings are very efficient buildings and properly designed. We can save around up to 50% of energy use, up to 39% of carbon dioxide emission, up to 40% of water use reduction, and up to 70% of solid waste reduction. So these are some benefits of green building design. There are many environmental benefits, economical benefits, and social benefits of designing green buildings. So green buildings are, inherently designed to make the best use of natural resources, and a green building is much more friendly to the environment than a normal building. We all know it has economical benefits also. So friends, there is a myth that designing or constructing a green building is a costly affair. No, I can prove it on paper, and I have done around 300 plus green building certification projects now, and I can prove it that going for a green building certification is not a costly affair. I mean, in fact, from the very beginning, right from the first day, you will start saving your money. And I can prove it on papers, I can prove it on energy models, daylight models, or any way you want it. Social benefits, we all know, friends, during COVID and post-COVID, now everybody understands the value of a home, a value of an office, which has good daylight, good fresh air. So, even earlier also the demand was good, but after this COVID thing, now offices, factories, warehouses, and many residential buildings, they are going for green building certification because they understand the requirement of a space which has proper daylight and proper fresh air. And we all know that green buildings are very good for the health of entire ecosystem that occupies it, and they also decrease the load on the local infrastructure. Friends, anybody can ask that, when we have so many green building certification programs in the country, in the world, then what is the need of GEM and what GEM is doing differently? So friends, I would like to share one very interesting fact with you over here that, although this green building certification was started in the country since 2000, and now it is almost over 20 years. So, and what we can see is the green building sector in the country is still at a very nascent stage of development, and hardly 5% of the buildings are, registered, are classified as green. So you will be surprised to know that hardly 7,000 buildings are registered, and around 3,000, 4,000 buildings are certified as green. So this 4,000 or 3,000 number is not that good. So it means, there is something which we are lagging, and ASSOCHAM has initiated this GEM Green Building Certification Program to complement the green building movement of the country. And that's why this program has been started, because we have the strength of 4,50,000 industry members with us. And with that support, we would like to make it a movement. Friends, we all know that, and as mentioned by Bagaji also, that 40% of the country's total energy consumption is because of buildings, and it is increasing at 8% annually. And if this goes like, buildings would account for over 70% of emissions by 2050, which is a very horrible number. According to the International Finance Corporation, around 70% of the buildings required by 2030 are yet to be constructed. So why we have started this program? Because we all know that India is a developing country, and around 70% of the constructions of the buildings are yet to be constructed in the country. So there is lots of scope for green building certification, designing a green building, and protecting our environment still in the country. If the construction industry is amongst India's fastest growing industry sector and growing at a rate of 9.2% and contributing about 10% of the country's GDP. Friends, government has started many residential construction programs like for housing for all. So this green building certification can not only save our environment, it can give jobs to many professionals, because government is focusing too much on providing housing for all, and where our architects, our engineers, our professionals can be associated, those who can help designing these affordable houses even more sustainable and green. So post-COVID, if green buildings can become a strong driver of economic growth and help to build back better by providing 9 million skilled jobs in both the renewable and construction sector by 2030. So it is not only protecting our environment and saving our mother earth, it is giving the opportunity of job to our skilled manpower also. So government in collaboration with banking sector can together provide fuel to the green construction sector. And if India embraces the concept of green building to meet huge demand, it would be a win-win situation, not only for the environment, but the economy also. So, we see green building from that perspective, because we are an industrial body. So our aim is to not only to protect environment, but to protect the industry also. So these are versions of GEM Green Building Certification Program. So this program is for new construction buildings, residential, factory buildings, warehouses, hotels, hospitals. So different types of reference guides have been generated, designed for different types of buildings. This is the scale on which we review the buildings. So say for example, if a project achieves 40 to 49 points, it will get GEM 1 point. From 50 to 64 point, it will get GEM 2 points. And similarly, if a project achieves 105 points or above, it will achieve maximum points GEM 5. GEM 5 is definitely the better than that of GEM 1. And friends, why GEM? GEM is the first and only green building certification of the country, which is the indigenous program, is on the latest guidelines of Bureau of Energy Efficiency, ECBC 2017 and NBC 16. No other program has been designed on ECBC 17 and 16. And the program includes sustainability, energy and water efficiency, fire and life safety, more greener area, indoor air quality, daylight, fresh air, human comfort, and is based upon the latest version of ECBC. So friends, this is the only program which has fire and life safety also in the program. No other green building certification program has fire and life safety in the curriculum. It is an affordable certification program. The fee is up to 30% less than other programs. This is the first indigenous program, as I discussed, which is based upon ECBC 17 and NBC 16 and has fire and life safety also. This is a great recognition for the buildings by India's century-old apex industry chambers for the buildings, and cost is between 6 to 10 rupees per square feet as compared to conventional building, which is nothing. And payback period is only 3 to 4 years. And friends, in GEM, we have a live monitoring station also. So this is the first program which has this facility that we can monitor, we can review the buildings online also. It's a 24/7 facility provided to the GEM compliant buildings, that all GEM compliant buildings and other buildings can be monitored 24/7, and we monitor electricity consumption, water consumption, air quality, and fire and life status also. This monitoring station is available online. And we are really proud to have MOUs with the CSIR, NIRI, Indian Institute of Architects, NEREDCO, FSCI, ISLE, GSCS, ISHRE, Smart Habitat Foundation, Air Quality Association, and ASHRE. And friends, this GEM Green Building Certification Program has been, empaneled with the Rajasthan government, with Rajasthan Building Bylaws 2020 for free extra FAR incentives for green buildings. So this is a major achievement, what we have done in last 2 years. And we are in the process of empaneling this program in other states also, in Punjab also, Uttar Pradesh also, and other states also. So the program has been listed by CRISIL also, along with other programs. You can see over the slide. This is the certificate and plaque we provide to the GEM compliant buildings. So friends, if you are an architect, an engineer, a developer, I would request you to please go for GEM Green Building Certification Program, and this plaque and certificate will be given to your project if this is a GEM compliant project. These are some of the GEM certified projects of ours. We have various commercial buildings, residential buildings, hotels, hospitals, and even various government buildings also. Many airports, many commercial buildings we have done in last 2.5 years only. And friends, if you come to, I would say that this GEM Green Building Certification Program requests you to save trees and save earth. So we request to provide more and more landscape area over the Mother Earth and preserve and plant trees on site. We request, we suggest to plant native and adaptive drought tolerant flora on site. On the other hand, GEM Green Building Certification Program requests you to save water. Green buildings can reduce the water usage by 30 to 40%. So we request you to design the rainwater harvesting system or storage system in the project, wastewater treatment system to treat wastewater from toilets and kitchen, then provide well plumbing in the toilets, use rainwater and treated water for flushing, HVAC and landscape applications, install low flow water fixtures, and best irrigation practices for the landscape. If you do this, you will be able to achieve at least 40 to 45% of potable water consumption of the building, and we can prove it. Otherwise, if you do not follow this, we will never know the worth of water till the well is dry. It's like that. The Green Building Certification Program, GEM, suggests you to save natural resources, because what we are doing is we are all making money out of our natural resources. So what does it mean? We request you to use the building construction materials which has a recycled content in it, like say for example recycled steel, glass, the fly ash bricks, the AAC blocks, the PPC cement, the tiles. So try to use the building construction materials which has a recycled content in it. And we request you to use the local building construction materials to save on transportation cost also. And not only the transportation cost, but to, if you are using the local materials, you are giving business, you are giving the job opportunities to the local skilled and semi-skilled manpower also. So this is in your best contribution to the society. So friends, so this way we can save our natural resources. And yes, we at GEM request you to not to use the hardwood and softwood. We suggest you to use the engineered wood products instead of using the hardwood or softwood. Also, we have discussed about saving trees, our natural resources, our water. So here we request you to save energy also. A green building, if properly designed, can reduce the energy consumption by 20 to 30%. What we have to do is we have to install the energy efficient air conditioning and electrical equipment, use LED occupancy and daylight sensors, design the buildings to best utilize the natural light instead of using artificial lighting, adequately size the windows to utilize the fresh air, optimize the facade glass selection for daylight and heat transfer, and install the imperishable energy resources such as solar PV, wind turbine, biogas. So as recommended by, as suggested by Surinder Bagaji also, that he has used many such features in his projects and buildings. So we can see that how efficient buildings have been designed by Sakar Foundation Bagaji, and he has utilized many such features. And not only now, he is utilizing these features since last 10, 20, 30 years. So Friends, because if you are designing a building, you are not designing it for 1 or 2 years. If you are designing a building, it means you are designing a structure which is going to last in 70, 80 years. So if you are designing an improper building, you will be harming your environment for next 70, 80 years. And if you are designing a good building, energy efficient, water efficient, sustainable building, you will be saving our Mother Earth for next 60, 70, 80 years. And friends, this is formula we all know. I mean, because we are architects and engineers, so this is not only our job, it is our moral responsibility to reduce, reuse, and recycle. Because, what we have done is nowadays we have made it a circle of taking and taking, and we are giving nothing back to our nature. And we have seen the recent impact of this, in Uttarakhand. We have seen that this disaster was not the natural disaster. It has been proven that this disaster which came in Uttarakhand recently, this was a man-made disaster. Because what we have done is we have, constructed dams on each and every river. We are damaging our natural, mountains, our rivers, our, natural flora and fauna. We are cutting trees. So what we have done is we are just, taking and taking from our Mother Earth. We are not giving anything back to the nature. So this is not good. And the result of this we are seeing, I mean, Corona and, then after this huge tragedy, this is man-made tragedy. So friends, we would request you to stop glamorous portrayal of business world with ugly truth. We are celebrating water day, Environment Day, Engineers Day, Architects Day, Doctors Day, and so. But what we are doing is we are hiding away the truth, which has always been the instant solution for mankind. So this is a short-term solution. But long-term solution is that we all together have to design sustainable buildings, sustainable built environment, energy efficiency, water efficiency we will have to follow. But otherwise, what will happen? This nature will become a historical topic in the near future. So friends, I would request you to stop fooling oneself and do justification to the environment, to Mother, and start designing the green buildings. Otherwise, this nature will become a historical topic in the near future. And what we will do is, to our next generation, we will show all this thing in the pictures only. Friends, coming back, in GEM, we have chapters in Punjab, Rajasthan, and Gujarat. Surinder Bagaji and his team is taking care of our GEM Punjab chapter. Surinder Bagaji is the chairman. We have chapters in Uttar Pradesh, West Bengal, Karnataka, and Maharashtra as well. And soon we are going to launch the chapters in Odisha, Jharkhand, and Tamil Nadu. So friends, this is the map over where GEM Green Building Certification Councils are there. So in just 2.5 years, 3 years, we have almost 50-60% of the country. And our team of architects and professionals are there. And friends, under GEM, we conduct the GEM Certified Professional Training and Examination also. So in last 1.5 years, we have trained and certified around 800 plus architects and engineers. We have made them GEM Certified Professionals. So now they are authorized to execute GEM Green Building Certification Program for themselves. So on this forum, I would request you all to please join us and go for GEM certification. Go for certified professional online examination also. This is an online examination and you can take this examination anytime from anywhere. It's an open book examination. We conduct this kind of physical trainings also in the engineering colleges, universities. So if anybody of you is interested, let us know and we will have a physical program in your college, in your campus on GEM Green Building Certification Program. Friends, we have done MOUs with many universities, educational institutions, architectural colleges across the nation. So many institutions are there. Let us all pledge to create a green and environment-friendly, sustainable country. So thank you so much, friends. Thank you so much.
Thank you, sir. Thank you for highlighting the potential that India, being a developing nation, has. That it has enormous potential in the field of energy efficiency and saving the energy, as a lot of our building stock is yet to be built. And if India embraces this green building movement, as you say, India surely will play a major role in our fight against the climate change. Thank you, sir, for sharing the various parameters and aspects of the certification program with us. I would request everyone in the attendees to kindly fill the feedback form that is now available in the chat box. And the YouTube link for the seminar is also available. Moving on to our next speaker, we have architect Sanjay Goyal with us, who will be talking about the role of green materials in energy efficiency. He is a practicing architect and the chairman of IIA Punjab chapter. He is also the director of Ludhiana Smart City Limited and an expert architect on All India Council of Technical Education. He is well renowned in both professional and educational segment of our architectural profession. Over to you, sir. Sanjay, sir, can you hear me?
Hello. Good afternoon, ma'am.
Good afternoon, sir. We can hear you.
Hello. Thank you, ma'am. Thank you. So, first of all, I welcome all the attendees on behalf of myself and Institute of Architects Punjab chapter. Webinar on energy conservation and energy efficiency. So, it's a good news that we are celebrating the Energy Conservation Week with PEDA. And thanks to Sakar Foundation for doing the needful for the masses. I welcome today's attendees from Department of Planning, Department of Agriculture, Department of Water Supply and Sanitation, TSPCL, Department of Technical Education and Industrial Training. So thanks to Mansi Architect, Engineer Gurpreet Kaur, and I liked presentation of Architect Surinder Bagaji on energy efficient architecture. It was a good one, another excellent experience for me. And Engineer Neeraj Arora shared his valuable experience with the topic GEM Green Certification. So my topic is green materials, the role of green materials in construction in today's scenario. Factors involved in sustainable green buildings. There are 5 basic principles of a green building. Sustainable site design, which is, I think, as architect, most important, that everything starts from planning and designing at site, that what kind of decision at concept stage made by an architect. Then water conservation and quality. We need that not only electricity, water conservation is also the need of the hour. Energy and environment, conservation of resources and reuse of materials, indoor environmental quality. So as architect, we have to keep all elements of nature into mind while planning and designing our built environment. We call them Vastu element as well. Some features of sustainable green building materials, recyclable building material process. You can see the slide that how the building materials can be used, reuse, recycle, reduce emissions. I think you can see my slides. Now you can see a section of building with features in sustainable green buildings. We can see how ducts work sealed with mastic and metal light colored roofing, alternative energy source, solar panel for water heater as well, native plantings, rainwater collection for rainwater harvesting, central vacuum system, Energy Star appliances and fixtures, low flow and dual flush toilets, and many more things which are required in sustainable green buildings. Now, the introduction to energy efficient building materials. An eco-friendly building material is one that increases the efficiency of energy used and reduces impact on human well-being and the environment. Examples are glass, bamboo, fly ash bricks, AAC blocks, eco-friendly insulation materials, etc. Building industry is one of the largest sectors which consume natural resources, manpower, energy, and economy. The growing demand for materials in building industry cannot be fully met by the natural resources or energy efficient traditional materials. Hence, there is a need to utilize available alternatives and innovative techniques to solve the increasing needs in construction. So lighting materials, we know how during the past decades, we have moved from one technology to another. Earlier it was CFLs and now to LEDs, to the use of skylights in the buildings. Lighting, CFLs, compact fluorescent bulbs are a profitable investment, save several times their purchase price through reduced electricity bills and fewer replacement bulbs because they last 8 times longer. LEDs are having long life. They are energy efficient, ecological friendly, durable, zero UV emissions, design flexibility, environmentally friendly. Skylights, we can see the ever increasing use of skylights in buildings, especially buildings with central courtyard, with atriums, where architects are preferring to use skylights as the buildings are air conditioned one, and skylights are very useful from many points. They are allowing the light into the building, heat can be avoided, and buildings are cool as per conditions. Polycarbonate sheet, general purpose glazing grade offers superior durability, unmatched design flexibility, structural integrity that easily surpasses laminated glass and acrylic alternatives. Polycarbonate sheet will transmit 80%, 86% of light. This product is UV stabilized. Technologies, solar panels, cool roofing. Solar panels. Solar power is a renewable resource available everywhere in the world. And it's a good news that during the past decade, especially, the use of solar panels has increased many folds. We can see not only in cities or with the commercial buildings, but even in villages or small towns, even for residential buildings, people are preferring solar energy, not only for the water heating or even for the electricity. So we can see a number of buildings, even the small building, residential building with solar panels on top. Solar PV technologies are small and highly modular and can be used virtually anywhere. Unlike conventional power plants using coal, nuclear, oil and gas, solar PV has no fuel costs and relatively low operational and maintenance costs. PV can therefore offer a price hedge against volatile fossil fuel prices. So either we have to go ahead for the warm roof or warm walls or cool roof or cool walls, depending upon the zone. As architect, we are designing buildings in the cool areas of J&K, Himachal, as well as in the hot areas of Rajasthan or NCR or Punjab, Haryana, we can say, where 80% temperature is hot in the hot climate zones, and in the cool areas, the 80% or 70% months are cooler. So benefit of cool roofs, a cool roof can benefit a building and its occupants by reducing energy bills, by decreasing air conditioning needs. We have seen many buildings where with the specialized consultation, the load of air condition has been reduced by 20 to 30% very easily, improving indoor comfort for spaces that are not air conditioned, such as garages or covered porticos, decreasing roof temperature, which may extend roof service life. Beyond the building itself, cool roof can also benefit the environment. Green interior techniques reduce the water use by the help of fixtures. Recycled content, steel studs for interior framing. Steel contains up to 95% recycled content. Flooring, certified wood, finishes, low VOC paints. You can see Build Center Living Building, opened on Earth Day of 2013 as the world's greenest commercial building. Now more natural materials, since we are using since decades, bamboo, shingles, mud bricks, fly ash bricks, and paved tiles. Bamboo, we all know, is very old and famous and environment friendly material. Since our childhood, we are seeing the use of bamboo in various activities. Bamboo has been in wide usage since ancient times as a low-cost material for houses, bridges, etc. It recently started appearing in designer homes as flooring, walling, and paneling material, even for scaffolding, reinforcement, roofing, walling, doors, and windows. Paved tiles. You can see normal paver tiles and glass paver tiles. Glass paver tiles allow water to drain through their hollow centers, and normal paver tiles decrease water quality, increase storm water runoff. Fly ash bricks. Adding fly ash to concrete reduces the energy needed in processing Portland cement. It requires less water, is somewhat easier to use in cold weather, and is less likely to crack. One reported drawback of fly ash concrete is that it takes longer to set up to full strength. Shingles. Roof shingles are a roof covering consisting of individual overlapping elements. We are using shingles in our 10 to 20% of houses where a client is preferring the sloping roofs, even in the non-hilly areas. These elements are typically flat, rectangular shapes laid in courses from the bottom edge of the roof up, with each successive course overlapping the joints below. Mud bricks. One of the most ancient construction material known to man is mud brick. Mud brick, also referred to by the Spanish name of a daub, which means mud or puddle earth, generally refers to the technique of building with sun-dried mud blocks in either load-bearing or no-load-bearing construction. Adobe, cob, compressed earth block, etc. can abate our demand for brick, stone, concrete, cement, steel, and wood. With natural heating, cooling, and ventilation, such structures can substantially lessen our consumption of energy and resources and eliminate pollution. I think more and more architects, especially young architects, should focus more on the environment-friendly green building materials. Otherwise, we have seen in majority of the cases during the past many years, all architects, especially the even younger generation, they are preferring the modern building materials, and many such materials they are using which are not environment friendly. And I think it is the right time to focus on environment friendly green building materials in our constructions and at design stage. Insulation materials, vacuum insulation panels, fiber insulation, structural insulated panels. Vacuum insulation panels. A vacuum insulation panel is a form of thermal insulation consisting of a gas-tight enclosure surrounding a rigid core from which the air has been evacuated. You can see the photograph showing the cross section. Structural insulated panels, foam board or liquid foam insulation core. Application is on unfinished walls, ceilings, floors, and roofs for mineral wool. Application is ducts in unconditional spaces. Other places requiring insulation that can withstand high temperatures, noise control, and withstand high temperatures. HVAC contractors fabricate the insulation into ducts either at their shops or at the job sites. Now, energy efficient glass. Double glass. The use of double glass is increasing in the building. Refractive glass as well. So control low emission glass. Double glass, you can see in the diagram cross section that how one glass pan and a second pan and in between gas filling and air is there. And there are many advantages, not only environment advantages, but noise, etc. also get reduced. Reflective glass. a metallic coating is applied to one side of the glass, it significantly increases the amount of reflection by the glass of both the visible and infrared range of the electromagnetic spectrum. This metallic coating can be applied to clear or body tinted glass. Solar control low emission glass. Glass will do three things. We all know with each part of the solar energy spectrum: reflect, absorb, and transmit. Solar control low emission glasses are designed to transmit high amounts of visible light and reflect IR. Passive solar low emission glasses are designed to transmit high levels of both IR and visible light. Reflective coated glasses generally reflect the most visible light. See this working in the given cross section. Low E glass has a special coating which is a poor radiator of heat and does not allow heat to be transferred to the outside. Instead, the low E coating actually reflects the heat back into your room. Now, types of low E glass. There are two types of low emission glasses: hard coat and soft coat. Hard coat low E glass is the more common variety. It is made by coating the glass during the production stages with a thin metallic oxide layer. It is durable and difficult to scratch. Soft coat low E glass allows more visible light in with little visible haze levels. Application of low E glass. Low emission glass was majorly used in commercial applications. However, it is now moving into the residential market as well. Low emission glass is ideally suited for office buildings, factories, homes, and public venues. Low E glass further improves thermal efficiency by cutting glare and preventing damage interior furnishing caused by ultraviolet rays. Few more benefits of low emission glass. Energy efficient glass in window can achieve energy efficient building envelope with greater design freedom, greatly reduced greenhouse gas emissions, reduced reliance on orientation and improved security, enhanced thermal comfort up to 5 degrees centigrade warmer in winter and 10 degrees centigrade cooler in summer, improved acoustic performance, reduced energy cost to heat and cool, a saving of approximate 40% to heat and cool the building. Few more examples of creative personalities. I could not stop myself. I want to discuss really the Raw Garden by great personality Nek Chandji in Chandigarh. This is one of the best example of best out of the waste. And recently I got a chance to visit Gujarat and see few cities, few upcoming smart cities in Gujarat, where local administration with the help of architects are creating the best use of waste materials in their cities. Same idea has been given in few cities of Punjab as well. I hope that being a lot of waste is generated by the industry and many more parameters, and government at district level shall make best use of the waste in their cities. And Nature's Raw Garden is one of the best example for the designers. You can see more art installation in India that use waste to promote recycling. Waste to Art Museum in Bhubaneswar. Sculptures prepared from waste and carved by national and international artists. Some notable sculptures include those of the Royal Bengal Tigers, Flying Eagle, the bust of Lord Buddha. E-waste into art installation in Mumbai. Haribabu Natsan, a Mumbai-based artist, creates art using electronic waste like old CDs, mobile phones, laptops, and part of microwave and washing machines, which might otherwise end up in landfills. We have also given idea to the Ludhiana administration to make, Ludhiana, we all know, is a city, Manchester of India, a city known for cycle production. we are trying our best to create a very big cycle out of the waste at public parks, and so that these act as a selfie point in upcoming smart city, and people can learn how hard work has been done by the industrialists and how the local architects are contributing into smart city mission by creating best out of the waste in the cities. You can see plastic monster near Mumbai's Bandra Worli Sea Link. It's very interesting. And now, after going through so many materials and things which architects, planners, engineers must do in their day-to-day life for making more sustainable green buildings, so that our buildings are as much comfortable to the architects or their clients, but for everyone. And the conclusion is that energy efficient materials play a vital role in energy conservation. Materials are there, we do take a decision, but we have to apply more mind that which material is coming from which source, how useful it is in the short run and the long run. I hope that planners and designers will be more careful in choosing the materials for their constructions and interiors. With proper materials and efficient design, we can limit damage to the ecosystem and reduce the use of natural resources like energy, land, water, and raw materials. Energy efficient measures can be integrated into new construction or retrofitted into an existing building. By adopting the various energy efficient methods, we can move towards creating an energy efficient and high performance building. These are my words, how the role of architect is very important, not only in creating modern and very attractive or cosmetically sound buildings, but the real aim is let us be linked to the nature. Let us plan and design such things which are not only in short run, but in long run are very useful for whosoever is using the building, whether it's a personal or public building. And let us come forward and work together to create more livable India. Thank you, everyone. Thank you, my dear friends.
Thank you so much, sir, for emphasizing the usage of materials like bamboo, glass, AAC blocks, solar panel integration, grass pavers, compressed mud bricks that can actually help us to make the building more sustainable. And also that with proper knowledge of materials and their properties, we can start saving the energy and the environment from the very initial step of a building construction. Now moving on to our question and answer session, I would like to ask, there has been a question raised to Engineer Neeraj Singh. What is the free FAR incentives that you talked about in your presentation?
Yes, thank you so much. First of all, this question is very interesting. So friends, if you are an architect or engineer, you must know that FAR means floor area ratio. So, I mean, and this floor area ratio is different in different cities and states. Say, for example, if your floor area ratio is 2.5, it means that you can construct 2.5 times of your site area. You know, in the site area, you can construct your built-up area can be 2.5 times of your site area. So this is the meaning of floor area ratio. So say for example, your site area is say 1000 square meters, say for example, then what you can construct is you can construct 2.5 into 1000 square meter. This much of built up area you can construct within your site. And this number is different in different states and cities, you know, as per the building and bylaws of that particular state or city. So this is FAR, and around 12 states, Punjab, Haryana, Rajasthan, West Bengal, Jammu and Kashmir, and various other, Chhattisgarh, they are giving up to 10% or 50% free FAR ratio. So say for example, if your permissible FAR is 2.5, and if you are designing a green building, the government will give you 10% of 2.5. I mean 0.025. This much of FAR area will be given to you for free of cost. Otherwise, the cost of this much of FAR can be in crores. तो मान लीजिए कि you are a developer and you are constructing a residential building or a commercial building, and if you want to design extra floors in your building, and if you apply for extra floor area ratio to the government, you will have to pay crores of rupees depending upon that how much area you are demanding. So instead of that, if you are designing a green building, you will be given this extra floor area ratio for free of cost because you are designing and constructing a green building. So this incentive is given by various state governments to the developers if they are designing a green building. So this is what extra FAR incentive meaning is. Thank you so much, Ji. Yeah, Mansi ji, over to you.
Yes, sir. There is another question, I think, so that is also directed to you, sir. It's when we talk of engineered wood, is it MDF or particle board wood? Nowadays, furniture makers prefer particle board woods, but it is seen to have durability issues.
Yes. So engineered wood means, these are MDF, ply boards, particle boards, LDF, or similar products. So why we are calling it engineered? We are calling it engineered because these type of products are being developed by recycled wood. I mean, the wood which is waste, they process this wood waste and make these particle boards, MDF, plywood, LDF, etc. These are some medium density fiber boards or some low density fiber boards like that. So these are all, we call it in engineering language, we call it engineered wood. So at SHM GEM Green Building Certification Program, and this is the only green building certification program I am repeating, which recommends not to use any kind of hardwood. तो जैसा आप लोगों ने देखा है कि कई बार दरवाजों के फ्रेम होते हैं, विंडो के फ्रेम होते हैं, दरवाजे होते हैं, आप सागवान या टीक वुड के बना लेते हैं. So at GEM Green Building Certification Program, we strongly recommend you not to use any kind of hardwood, and instead of hardwood, you can use engineered wood. क्यों engineered wood? क्योंकि engineered wood जो है वो wood waste से जनती है, wood weight से generate होती है, उससे बनती है. So you can utilize that engineered wood. One. दूसरी बात ड्यूरेबिलिटी की. So if you are using quality MDF plyboards वगैरह अच्छी कंपनी के branded, then there will not be any any doubt on the quality or durability, because these kind of boards are very much durable. In fact, nowadays the doors, door frames, and many kind of furnitures can be developed through these boards if they are of good quality. One. Second, we have many kind of alternative materials, many kind of rapidly renewable materials like bamboo. So use of bamboo is, I mean, you can use bamboo for any kind of material. In fact, nowadays floor tiles are also available in bamboo. So bamboo floor tiles are available, and you can make any kind of very beautiful, sophisticated furniture from bamboo. Good point with bamboo is that this furniture is very much durable. You can put this material in the open air, under the sunlight, under the water. It will not harm anything to the bamboo. Second good thing with bamboo is that it is rapidly renewable. ये बहुत जल्दी डेवलप हो जाता है, इसकी हैंडलिंग अच्छी है, इसमें कोई दीमक वगैरह का, कोई टर्माइट का कोई इशू नहीं है. So I mean, now if we want to save our mother earth, if we want to save our trees, we will have to look for some alternative materials, say for bamboo, jute, rubber, or engineered wood kind of. So this is my request to you all.
Next question is directed towards Sanjay sir. It concerns IIA Punjab chapter. The person is asking, is IIA Punjab chapter hosting any conferences on such topics where architecture students and research scholars might present their works? So I think so. It's a new initiative you will have to think about, sir.
Okay, ma'am. Am I audible?
Yes, sir.
Okay, thank you. And it's a good question. First of all, as usual, Institute of Architects Punjab chapter, even in collaboration with Chandigarh chapter and more chapters in North India, we are going to organize many seminars, panel discussions, and lectures. All scholars and students are most welcome. They can contact any office bearer of IIA Punjab chapter or Chandigarh chapter or Archistudent Bagaji, so that we can definitely give a chance to each and every speaker to share his or her experience on our platform. All are most welcome from our chapter side.
Thank you so much, sir. I would like to request all the attendees to kindly fill in the feedback forms available, and as you asked for the conference, you can leave that with us in the feedback forms. And moving to our next question, that is regarding the material. What material can replace wood other than tin sheets and plastic for inner side of slant roof so that the loft could be used as room in future? Sanjay sir, will you be answering this question?
Yeah. Madam, please repeat the question.
What material can replace wood other than tin sheets and plastic for inner side of slant roofs so that the room is usable in future?
Yeah. So there are two issues of this question. One is the usability, that is the architectural point that can be put to use by planning and all. If that is related to insulation or green material, definitely undertake insulation can be done so that it is more environment friendly. Both things are possible. The replacement of tin wood is there, as well as the habitability and how to use that space. That is also possible.
Thank you, sir. It brings me immense pleasure to inform everyone that apart from PEDA asking us to make 50 attendees join this program, we were able to reach more than 150 people in every session that we have conducted. It brings me immense pleasure to share that all the participation has helped us bring these programs to a success. Moving on, I would like to invite Architect Ramneet Garhyal to conclude the session for us. Over to you, Ramneet ma'am.
Good afternoon, everybody. So, good evening. Good evening. So, since I've listened to all the expert talks, Architect Surinder Baga's talk was mainly focused on case studies of projects done in India and abroad, which are rare examples of energy conservation. He even highlighted the necessity to design buildings to suit local climate conditions. Engineer Neeraj introduced a new GEM, Green Building Certification Program, launched by ASSOCHAM. I've studied about it, and I think it is going to be very popular in near future. The Associated Chambers of Commerce and Industry of India, ASSOCHAM, the century-old organization, executes the GEM Green Building Certification Program for the sustainable design and development of buildings and related developments. The objective is to ensure future buildings move towards environment-friendly methods of design, construction, and operations. With this program, ASSOCHAM awards GEM Green Building Certification Rating to GEM compliant buildings. GEM Green Building Certification Program is based upon BE's Energy Conservation Building Code and National Building Code. Architect Sanjay Goyal spoke on the urgency of using green materials. He advised that there are many materials in the market which are manufactured with less energy or produced with waste materials like fly ash. He even stressed on the need to learn from Chandigarh's rock garden, where late Nick Chanji used all waste materials, yet they are looking very beautiful. So thank you so much, everybody. Thank you for joining us.
Thank you so much, Ramneet ma'am, for concluding the session and giving us all the brief that we talked about in this webinar. Now, I would like to invite Architect Arpan Agarwal from Jalandhar to present vote of thanks to all our attendees and the panelists. Over to you, Arpan, sir.
Good evening, everyone. Hello, I am audible.
Yes, sir, you are audible.
Yeah, it is my pleasure to propose a vote of thanks for the contribution of each and everyone for having made this webinar a memorable event. We would like to express deep gratitude to Punjab Energy Development Agency and BEE for giving us this opportunity to meet and exchange knowledge. Special thanks to all officials from PEDA for their valuable support. We would like to convey thanks to Engineer Gurpreet Kaur for her welcome note and Architect Guneet Khurana for his introductory address. We are thankful to expert speakers Architect Surinder Baga, Engineer Neeraj Arora, Architect Sanjay Goyal for their nice presentation. We are grateful to the officers and staff of the Department of Planning, Agriculture, Department of Water Supply and Sanitation, PSPCL, Department of Technical Education and Industrial Training, for attending this program, and Sakar Foundation, Chandigarh, for conducting this program. We are grateful to office bearers of IIA Punjab and Chandigarh chapters for supporting this program. Our special thanks to all of you for spending your valuable time for our sake. Thank you very much indeed, all of you. In last, I would like to thank Ms. Mansi for her wonderful comparing of the webinar and Architect Ramneek for her conducting remarks. Our deep gratitude is due to all media personalities for their wholehearted support for this program. Thank you, all of you.
Thank you so much, Arpanji. In the end, I would like to request all the attendees to kindly fill in the feedback form available in the chat box. And if there are any queries left, though the answers will be mailed to you, the portal will be open for the next 10 minutes. All the attendees are also requested to follow the YouTube link and circulate it as much as possible. Thank you all. Hope you all have a remarkable day ahead. I request you all to join us in the coming sessions and make those sessions a success as well. Thank you.
लो सर हो गया ठीक है ਤੇ ਤੁਸੀਂ ਸਰ ਆਰਾਮ ਨਾਲ ਸੋਚ ਵਿਚਾਰ ਕਰੋ ਠੀਕ ਹੈ